Welcome to the video on kurtosis. Let's get the title up on the board. Kurtosis. Again, let's just start with a definition here, a working definition of kurtosis. Whereas skewness was talking about the asymmetry, kurtosis is really describing or describes the amount of extreme scores. In other words, more or fewer. Relative to, or departures, I guess you would say, from what kind of scores you would get from the standard normal curve, which has a mean of 0 and a standard deviation of 1. Both with kurtosis and with skewness, you can kind of get a feel for this by kind of graphing, doing a polygon graph, a frequency polygon, or a histogram plot. Either one of those would kind of give you a sense of this deviation from it, but the skewness and kurtosis values give you the exact mathematical departure from it. And so we need to kind of go through, I've left the data on from the skewness piece. So again, if you remember, column 1 here was our index of summation. We had 10 scores, so we had 10 different I levels. Then we had X sub I, so when I equals 1, this is in column 2, our raw score was 7. When I equals 2, the raw score was 8, and so on and so forth. And when we summed column 2, we got 60, and then we brought the 60 down here into the mean equation, and we found that 60 divided by 10 was 6, so our mean was 6. We put in 6 for 10 sixes corresponding to each of our 10 raw scores. Then we did this fourth column, which was the x sub I minus x bar, which was taking column 2 minus column 3. So 7 minus 6 was 1, 8 minus 6, 2, 8 minus 6, 2, another 7 minus 6, 1, so on and so forth, all the way down through the last or 10th value here, which was 8 minus 6 was 2 again. So if you summed all of these deviation scores in column 4, then you would get a sum of 0. And again, these are how far each of the raw scores are away from the mean score, that measure of central tendency. So in column 5, the x sub I minus x bar squared, we're squaring these deviation scores. And when we do this, we get a sum of 66. We call this, by the way, this sum of 66 here, the sums of squares indicated by SS. That is the sum of the squared deviation scores, called sums of squares. We put those sums of squares and enter it into the numerator of this variance formula here. So, and then we're going to divide by our degrees of freedom n minus 1 to get us variance. So 66 divided by 9 gave us our 7.33. And then this 7.33, we take the square root of it to get S, which was our standard deviation of 2.71. From that, we used our formula for a z-score, which is anytime we want to get a z at any I level, it's going to be the x of that I, the raw score, minus x bar divided by the standard deviation. And so this numerator piece, and I'll just, I guess, do this in red, this numerator piece here for the z-score right here is this column 3 piece right here. And so all these 10 values we're going to substitute in to get a z-score for each one of them. And we've done this, and we're going to divide by standard deviation. So we did this right here. We took 1, it became our numerator, divided by S, which was 2.71 to get 0.37. And then I showed you an example here of 2 divided by 2.71, which is 0.74. We calculated a z-score for all I equals 10 values here. And in the skewness video, we cubed these. And so now we want to talk about what the formula is for kurtosis. So kurtosis is going to be a gamma as well, but it's going to be gamma 2. Skewness is gamma 1. Kurtosis is gamma 2. And so its equation is going to be summing from I equals 1 through n of all of the zi to the fourth divided by n minus 1 as our degrees of freedom. And so now what we need to have is we need to have an additional column out here that's going to be z to the fourth, and what it's going to be is taking this z-score here and multiplying it 4 times. Okay, so taking this example here again, it's going to be 0.37 multiplied by 0.37. You get the idea here. Multiplied by 0.37 multiplied by 0.37 to give us, our first value of 0.019. 0.019. And if we continue to take these on, then we'll have 0.29, 0.29, 0.019, 1.5, or 1.50 if you wanted to, 11.59. This, of course, 0 here. 0 to the fourth is 0. 1.1 to the fourth is going to be our 1.50 again. 0, 1.50, and then 0.29 again. And you notice in the z column, when we had the regular z-scores, so this column right here, we had positives and negatives. Positives meant that the raw score was higher than the mean, and negative z-scores meant that the raw score was less than the mean. Well, when you square something, you'll get rid of the negative, but if you cube it and take it to the third power, you'll maintain the negative. And so that's what we have here. You're seeing, for instance, this negative 1.33 here, we keep that sign. But when you take it to the fourth power, the fourth moment away, if you will, from the mean, you're going back to a positive again. And so you'll have to subtract that back out later, because what I haven't shown you yet for the rest of the formula here, the rest of this formula is minus 3. And so the whole complete formula then for kurtosis is this. And so what we need to do then is kind of sum this column, which will now give us 17.02. And so if we substitute this value in here for the numerator, what this will become is gamma 2 equals 17.02 divided by n minus 1, which is 9. And let me run this on the calculator here real quick. 17.02 divided by 9 equals 1. Oh, we almost forgot something here, didn't we? Let's not forget this other piece here. What did we forget? We forgot our negative 3. So let's build our negative 3 in here. Then we'll reduce these terms. So gamma 2 is this piece here, reduces to 1.89, and you want to subtract 3 from that. Gives you an overall gamma 2 answer of negative 1.11. So that is the answer here. So again, if not too dissimilar to skewness, if you want gamma 2, if gamma 2 equals 0, then you have symmetry again. In other words, you have, that is, normal, a normal curve. If gamma 2 is positive above this, you're going to get a very narrow looking curve. It's going to be very narrow or peaked, which means you're going to have less extreme scores. And if gamma 2 is negative, then you're going to have a very broad, flat, or broad shaped curve. Well, that would not be broad. And that means you're going to have more extreme scores. Again, we're going to follow this up with a video on the actual shapes of these things, and then probably something tying it all together. But that is the math behind being able to calculate kurtosis. Thanks for watching the video.